Oil refineries. Crude oil is extracted from oil deposits in Earth's crust and shipped or piped to refineries. It consists of a combination of many types of hydrocarbons. These can be separated out into various products that are used in different ways. Processing and treatment. Crude oil fractions that have lower boiling points are more flammable and burn with a cleaner flame. As a result, they tend to be in higher demand than heavier fractions. To meet demand, some of the heavier fractions, which are composed of long chains of molecules, are converted into more useful and valuable products through a process called cracking. This often involves breaking down the molecules using heat or a catalyst, such as silicon dioxide or aluminum oxide. Fractional distillation. The different hydrocarbons in crude oil have varying boiling points. This means that they can be separated out by evaporating the oil, then condensing the gases into different products at different temperatures. This takes place in a distillation tower. Substances with lower boiling points condense higher up the tower. Trays at calibrated heights collect the substances, known as fractions. The distillation tower. An oil refinery's distillation tower contains a vertical column divided into horizontal sections containing trays that collect the different fractions. Step 1. Desalted crude oil enters furnace. After salts and some other impurities have been removed, crude oil is sent to the distillation furnace. There, it is heated with superheated steam to around 750 degrees Fahrenheit. Step 2. Oil enters the column. The heated crude oil enters the distillation tower. Most of it rises up the column as gas, but some heavier fractions remain liquid. Liquid collected at the base of the column is sent to the reboiler. Remaining liquid oil is reheated and fed back into the column. During this phase of the process, there are three types of liquids made. The first is residue. Residue is oil that does not boil in the tower and is collected in the bottom tray. It is later turned into asphalt, which is widely used in road making. The second is gas oil. This contains a broad range of products including oil lubricants and heavy fuel oils used by ships' engines and in power stations. The third is diesel. Less flammable than gasoline, diesel is an important fuel used in generators to produce electricity and to power vehicle engines. Step 3. Distillation. At a certain height and temperature within the tower, a fraction condenses into liquid, separating out from the rest of the oil vapor, which rises up the column. During the initial stage of distillation we generate kerosene. Kerosene is used as a fuel in heaters or refined further to produce potent jet fuel. Step 4. Vapor rises. Fractions of hydrocarbons with lower boiling points continue to travel up the column further than heavier fractions, passing through holes and trays as they rise. Vapor rises, passing through holes and trays. At this stage we see two new substances. The first one is heavy naphtha. This fraction is often processed further, for example, by cracking, to produce gasoline and other crude oil products. Additionally, we find straight-run gasoline. This is a gasoline produced without further chemical processing. Almost half of crude oil is refined into gasoline used as vehicle fuel. Step 5: Tray collection. At each level in the column, as a fraction of the oil vapor cools and condenses to a liquid, it is collected on a tray and piped away for processing and storage. Pipes called downcomers channel liquid down from one tray to another. Because of this, two final substances are made. The first is light naphtha. This fraction is often used to produce ethylene, which is used to make many plastics including polyethylene. The second is liquid petroleum gas. The lighter hydrocarbons, such as propane and butane, remain as vapor. These are processed into bottled gases and used in heating and cooking. Treating oil spills. Oil tanker accidents and pipeline leaks can release crude oil into the environment, causing catastrophic damage to ecosystems. The cleanup process at sea can involve using long booms to skim the surface oil from the water as well as chemical treatments. Chemicals called dispersants are sprayed into water. Solvents in dispersants penetrate oil slick and enable surfactants to act on oil. Surfactants decrease surface tension, enabling individual oil droplets to break from oil slick. Droplets are dispersed and over long periods are degraded by microorganisms such as bacteria. And that's the process. Thanks for watching. Remember to like this video, subscribe to the channel, and share it with someone that you know. We'll see you in the next one.